So I'm going to try to explain this very simple circuit. This is fundamentally trying to show the purpose of having a capacitor and a resistor, right? So I wanted to show that purpose there. My resistor is a little bit like the dark side of the moon kind of a thing. Yep, now it's a bit better. Okay, so I'm not gonna explain too much. I've got power coming in from these guys over here. It goes down the power rail over here, right? On the power rail over here. So I've also got a switch over here to show you the difference. So first, I'm gonna kind of explain if I didn't have a resistor, right? So I'm gonna switch on the power, and then I'm gonna turn it off. Look at the LED properly. You would see a fade out effect. It doesn't cut off; it fades out. Quickly fade out, right? Right. So that's because if I look at my switch over here, right? My switch is going towards the wire, which means this is negative. When power gets cut off, when the switch is open, what happens is capacitor sends power, dissipates, goes through here, and then it goes out straight. So the circuit is pretty, there's no resistance, so I guess what happens is the electrons or the flow is pretty fast. So that's why everything goes out really fast. So it kind of discharge. But if I understand this correctly, right, so when the power cuts off, the power that's stored in this capacitor goes to the negative, it goes to here, it goes to here, it goes to the negative, powers up this LED, and then just discharge pretty fast. That process of discharging power is pretty fast. So it goes up, it lights up, that's it, finish. Right? So that was what I had initially. I saw the fade out effect, but it wasn't really that impactful. So now I'm going to switch my switch to the other side. So now my negative part of my LED is connected to the resistor. Right? So now we're going to see a difference now with the resistor. So which means when the power that is inside the capacitor gets discharged, as it's flowing down, this is going to resist the current flow. So the current is going to be a bit slower. Right, much more slower. It's like everybody's rushing out from a building, but the door is really small, so it's going to be slower. So the amount of electron or people coming out is going to be much lesser. So this will take a longer time. So the flow of current or electron going out is much slower. So this would last a bit longer. Let's have a try, shall we? So power on, power off. Power on, fade out. Power on, fade out. So that I thought was pretty cool, and you can't really tell if you don't really compare it. Let me switch it on to the wire straight away. It's tricky to switch over. Okay, now let's look at it. It fades out 1000. It's gone. 1000. But if I go to the other one, 1000, 2000, 3000. So it's about it actually takes 3 seconds to fade out with the resistor. Right, so I thought that pretty cool. Right, so that's really is it.